Hello students, welcome to Vyas Edification Kota. In this session of NCERT discussion, we'll be picking up a topic from class 12th NCERT, and what are we going to discuss? We'll be discussing the chapter Matrices. This is the third chapter from your book, the NCERT part 1 of class 12th mathematics, and today we'll be discussing in this session exercise 3.1. So let's start with this first question based on this exercise 3.1. What does the first question say? Let's talk about this one. In the matrix A equals this big matrix, write the order of the matrix, okay, the number of elements in this matrix, write the elements A13, A21, A33, A24, A23. These are the elements that we need to identify in this matrix. Okay. Now, how do we go about finding those things? So, let's recall what a matrix looks like and how do we represent a matrix. Let's see a general matrix of some order. Some order, yes. What does the standard representation of a matrix look like? So, a matrix of order m by n can be written as this Aij, where Aij is element in the ith row and jth column. Aij is the element present in the ith row and jth column, and yes, the order is m by n, where m represents the number of rows and obviously the value n represents the number of columns. Let me write that. This represents the number of columns. Okay. What next? This particular matrix, this is a short form, the longer version or the elaborate form in which I can write the matrix as this. What do we have over here? The first element would be A11, which is actually equal to the first row, which is actually lying in the first row and first column. Now this here is the first row. The rows are horizontal. Rows are actually horizontal. The columns are vertical. Column C. C can be written as this, right? C. The columns are vertical and the rows are horizontal, as you can see, right? So A11 is this. Then we have A12, the first row and the second column. Then we have A13 and correspondingly we can have A1n. The first row, third column, first row and last column, that is the nth column. That's what you can observe, right? Similarly, in the second row, what you'll have is A21, A22, A23. These are the elements that will be present in the second row. This represents second row, first column, second row, second column, second row, third column, second row, third column, right? And similarly, at the end, you'll have A2n, which implies second row and nth column. Correspondingly, we can have the last row, that is mth row, first column, mth row, second column, mth row, third column, and mth row, nth column in this manner, right? These are the elements and that's the complete form. These are all the elements present in this matrix. How many elements do you think are there? The number of elements would be actually equal to the number of rows times the number of columns. That is the product Mn. That's the product Mn. That is what you'll be having as the number of elements. Okay. Now, keeping these things in mind, we can attempt this question very easily, right? What does the question say? The question simply asks us to find the order of this matrix over here. So, for order, we simply require the number of rows and the number of columns. Let's take a look at that. In the first part, we simply want to find the number of rows and number of columns. How many rows are there? There are 3 rows. How many columns do you think are there? There are 4 columns, as you can observe. So the order would be 3 by 4. We'll read it as 3 by 4, right? Okay. What about the number of elements? Number of elements is actually equal to the number of rows times the number of columns, which is 3 into 4, which is 12. Simply 12. That's what we have, right? We simply multiply these two together and we get the number of elements in this matrix. What about the third part? Now, the third part is also very simple. Third part, we need the values of these few elements, which are A13, A21, A33, A24 and A23. Let's try to find these values, right? Let's try to find the values of these elements, right? So, A13 represents first row and third column. In the first row, we have to select third column, which is this. The element present at that location is 19. What about A21? A21 represents second row and first column, this particular element over here. This is equal to 35. What about A33? A33 represents the third row and third column. Third row and third column is this. This is minus 5. What about A24? A24 represents the second row and the fourth column. This is 12. A24 is 12. What about A23? A23 is second row and the third column, which is 5 by 2. So this is equal to 5 by 2. And yes, that's the complete solution of this question. You can take a look at it completely, and that's all for this question over here. Let us take a look at this question next. If a matrix has 24 elements, what are the possible orders it can have? And what if it has 13 elements? There are two questions involved in this. If a matrix has 24 elements, what are the possible orders it can have? Let's take a look at this. For forming a matrix, we have to have number of rows, some number of rows and some number of columns, and the total number of elements. For example, for a matrix of m by n order, the total number of elements is equal to mn. That's the total number of elements. For example, let's say there are 3 rows and 2 columns, so number of elements would be actually equal to 6, as you can clearly observe, right? There can be another case, let's say if I have another order, maybe 2 by 3. Now what happens in that case? Number of elements would be equal to what? Number of elements is again 6 only, right? Multiply 20 through it. Let's take another example. What happens in case I have 6 rows, I have a matrix having 6 rows and 1 column. 6 rows and 1 column, yes, 6 rows and 1 column, something of this sort. This is a matrix having 6 rows and 1 column. How many elements do you think are there in this? This also has 6 elements. Similarly, I can have a matrix having order 1 by 6, that is 1 row and 6 columns. What do you mean by that? 1 row and 6 columns, yes. I can have this element. This is a matrix having 1 row and 6 columns, as you can observe, right? And the order is 1 by 6, and yes, number of elements would be 6. Now what is special about these orders? When we consider this particular number of elements, what is special about these orders is, as you can clearly observe, these are nothing but the factorization of this particular number 6. We are writing 6 as product of 2 numbers, right? We are writing 6 as product of 2 natural numbers for that matter. That's what you can observe. And once this particular concept is clear to us, then we realize that if a matrix has 24 elements, let's try to write 24 as product of 2 factors, which are natural numbers, right? And those will be the possible orders of the matrix, right? So 24 can be written as, let's try to begin with the smallest one. 24 can be written as 1 by 24. The smallest number of rows can be 1, right? The next factor that I can think of is, as you may observe, 24 gets divided by 2, and what you get is 2 by 12 is another possible order, right? Okay. We could also have 3 by 8. 24 gets divided by 3, right? 24 has a factor 3. 24 has another factor 4 as well, right? This is 4 by 6 as well. What else? After that, 5? No, 5 is not a factor of 24. 6 is a factor of 24. And what happens with 6? 6 times 4 is what you get. So 6 times 4 is already, 4 times 6 is already present. 6 times 4 is nothing but reverse of this. We could also have 6 times 4, 6 by 4, right? This is one possible order, this is another possible order. What happens in case of 6? After 6 we need 7. No, 7 is not a factor of this. The next factor would be 8 only, and the possible order that you would get is 8 by 3. After that, obviously, the next would be 12 by 2. Do I need to check 9, 10, 11? No, you don't need to check 9, 10, 11. The order will be this only. This is 24 by 1. Next. Right? So this is how you find the possible orders of a matrix having 24 elements. There are 4 plus 4, 8 possibilities. 8 possibilities in total, right? Those are the number of possibilities. Next, what are the possible orders? These are the possible orders. What if it has 13 elements? What if the matrix has 13 elements what are the possible orders the matrix may have. So let's try to factorize 13 as well. Now when we realize that factorizing 13 does not give me much options, this can be 1 by 13 or it can be 13 by 1. Does 13 have any other factors? No, 13 does not have any other factors. Only factors are 1 and 13. So this is one of the possible order and this is another possible order for this matrix having 13 elements in total, as you can see over here, right? Is that all? Yes. Let me get aside. You can take a look at this. This is all in this question over here. Let's talk about this question. If a matrix has 18 elements, what are the possible orders it can have? Okay, pretty interesting. 18 elements. So let's factorize 18 and see what are the possible orders it can have. We'll try to factorize 18, right? So 18 can be factorized as factors, 2 natural number factors. In terms of 2 natural number factors, this is 18 can be written as 1 by 18, yes, or it can also be written as 18 by 1, yes, right? Another factor of 18 is 2. The next factor is you can think of is 2. 2 by 9 is what you get. 3 is also a factor, yes. So this is 3 times 6. 4 and 5 are not factors. The next factor is 6 only, and yes, the possible order can be written as 6 by 3. The next possible order would be actually the reverse of this, which is 9 by 2, and the next possible order would be 18 by 1. As you can clearly observe, there are 6 possibilities. There are 6 possible matrices, 6 types of possible matrices, 6 different possible orders for a matrix having 18 elements, as you can observe. What if it has 5 elements? In case the matrix has only 5 elements, let's try to factorize this. 5. So 1 is a factor, 5 is a factor. Are there any other factors? No. So 1 by 5 and 5 by 1, these are the only possible orders that a matrix having 5 elements can have. Right? Is that all? Yes, that is all in this question. Let me get aside for you to take a look. That's all in this question. Let's take a look at this question. Construct a 2 by 2 matrix A equals Aij whose elements are given by this, this or this. There are 3 possibilities, 3 parts of this question. So let's solve each of them one by one. But first, what do you mean by a 2 by 2 matrix and this symbol? Let's take a look at this. A is a 2 by 2 matrix. Aij 2 by 2. So this matrix would have 2 rows and 2 columns. This matrix would have 2 rows and 2 columns. In total 4 elements. And what are the elements? The first element, first row, first column. This element would be represented by A11. This is first row, first column. First row, second column, the element would be A12. Second row, first column, the element would be A21. And the second row, second column, the element would be 22. Basically, these are different values of I and j, which give us these elements, right? And now we'll solve each part. Let's take a look at the first part. For first part, it is given that Aij equals I plus j whole square complete divided by 2, right? This is what we have. Since this is known that Aij is equal to this, can we find A11, A12, A21, A22 very easily? Yes, let's do that. A11 is equal to 1 plus 1 whole square by 2. Okay, we'll find all 4 over here. This is equal to 2 square over 2, which is actually 2. So the value of A11 that I am getting is 2. What about A21? Let's find A21 over here, right? A21 is 2 plus 1 whole square by 2. What is that? This 2 plus 1 is 3. 3 square is actually 9 divided by 2. Already there. What about what happens in this case? This element. This is A21. So let's try to find A21 over here. Okay, we have found A12 over there. Sorry, A21 over there. We were supposed to find A12 over there. Okay, never mind. Never mind. Let's change that, or okay, let's change that. Let's not worry too much for avoiding mistakes. This is A12. This is A12. I'll solve A12 over here, which is 1 plus 2 whole square by 2, which is again 9 by 2, and A21 is 2 plus 1 whole square by 2, that is I plus j whole square, which is again 3 square, that is 9 by 2, as you can observe. The last element, as you may observe, is A22, which will be equal to 2 plus 2 whole square whole divided by 2. What is that? 2 plus 2 is 4. 4 square is 16 upon 2, which is equal to 8. 16 over 2, which is equal to 8, and yes, those are the elements. Now, do I get my matrix A very easily? Yes. Therefore, matrix A, which is a 2 by 2 matrix, for this particular part would be equal to what? This is the first element over here. A11 is 2, A12 is 9 by 2, A21, as you may observe, is 9 by 2, and A22 is 8. This is my answer for part 1. As you may observe, this is my answer for part 1, clearly. What next? Let's move ahead and solve part 2 after this. Okay, let's take a look at part 2 after this. What do we have in part 2? Part 2 says Aij equals I upon j. Okay, so once again I need A11, okay, I need A12, I need A21, and I need A22. Let's try to find them. A11 is I upon j, that is 1 upon 1, which is simply 1. Okay, Aij is I upon j, A12 would be actually 1 upon 2. That's all. A21 would be 2 over 1, I upon j, which is actually 2. A22 would be 2 over 2, which is simply 1. This is what you get. And therefore, the matrix A that we obtain in this part would have elements A11 is equal to 1, A12 is equal to 1 by 2, A21 is 2, A22 is 1. This is the matrix A for part 2, as you can observe over here. Take a look at this complete, right? And then let's talk about part 3 after this. Let's talk about part 3 after this. What does part 3 have in here? Let's take a look at this. Aij is equal to I plus 2j whole square whole divided by 2. That's what we have, right? So let's try to find A11, A12, A21, and A22 over here. Okay, these are the 4 elements that are required, right? What about A11? A11 would be equal to 1 plus 2 times 1, right? Ij. 1 plus 2 whole square divided by 2. What is that? This is 3 square, which is actually 9, and divided by 2. That's what we have. What about A12? A12 is equal to 1 plus 2 times 2, right? I is equal to 1, j is equal to 2. This becomes 2 plus 1 plus 2 times 2 whole square divided by 2. This is what we have, right? In the bracket, what does that simplify to? That simplifies to 2 times 2 is 4 plus 1 is 5. 5 square is 25 divided by 2. This is what I get, right? What happens in case of A21? Let's take a look at this. A21 would be 2 plus 2 times 1 whole square divided by 2. What is this equal to? Let's take a look at this. This is 2 plus 2, which is 4. 4 square is 16 by 2 is simply 8. 16 by 2 is simply 8. This is what you get. Okay. What happens in case of 2, 2? The value of I is also 2. The value of j is also 2. This becomes 2 plus 2 times 2 whole square divided by 2. What is this equal to? This is 2 times 2, 4 plus 2 is 6. 6 square is 36. This is 36 over 2, which is equal to 18. These are the elements. Once we obtain these elements, then forming the matrix is very simple. Therefore, A matrix is equal to what? A11, which is 9 by 2. A12, which is 25 by 2. A21, which is 8. A22, which is 18. Those are the elements that I have. That's the complete matrix that I obtained over here. This is part 3 for me, right? And yes, that's the complete solution of this question. Let me get aside and you can take a look at this complete. Let's discuss this question where it says construct a 3 by 4 matrix whose elements are given by this and this. There are two parts of this question and we are supposed to construct a 3 by 4 matrix. Now what does a 3 by 4 matrix look like? Let's take a look at that first. A 3 by 4 matrix would have 3 rows and 4 columns, and yes, it would look like this. A 3 by 4 can be written as Aij 3 by 4, which will look like this. 3 rows and 4 columns. The first element present in the first row and first column would be A11. Then you have first row, second column. Then you have first row, third column. Then you have first row and fourth column. There are total 4 columns, right? That's what you get. Okay. What happens to the next one? This is the second row, first column. This is second row, second column. This is A22. The second row, third column would be A23, this element. This element would be A24. The second row, fourth column. What about this one? This is third row, first column. Third row, second column. Third row, third column. Third row, fourth column. And yes, these are 3 rows and 4 columns. As you can observe, this is a 3 by 4 matrix whose elements are these. What happens in case of the first part? Let's try to find each of these elements for finding the matrix as in the first part. Let's try to do that, yes. So for first part, what do I know? I know that Aij is equal to half times modulus of minus 3i plus j. This is what it is equal to, right? And since I'm supposed to find all of these, let's try to make a grid over here first of all. Let's construct a grid. Okay, just a minute. Let me take lesser space. Yes, this is the grid. And grid, yes, let's make a partition over here. Let's make another partition over here and a partition over here as well. So A11 will be solved over here. A12 would be solved over here, right? Calculation errors can be avoided, like all of this makes your calculation look easier, look simpler, right? A13, A14, right? What happens in this case? This is A21, A22, A23, A24. We'll solve each of these here. A31, A32, A33, A34. This is what we'll do, right? So let's try to solve each one. This is a grid. The first one says A11. A11 would be equal to half. This is minus 3 plus 1. The modulus of minus 3 plus 1. Minus 3 plus 1 is actually equal to minus 2. The modulus is equal to 2. So this is 2 upon 2, which is equal to 1. That's the value. This is equal to 1, right? Next, A12. A12 would be equal to 1 by 2 modulus. This is minus 3 plus 2 modulus. Minus 3 times 1 plus 2. This is what you get. What is this equal to? This is minus 1. The modulus is 1 upon 2. So this is equal to 1 over 2. This is equal to 1 over 2 over here. What happens in case of A13? This is equal to half modulus minus 3 plus 3. And you may observe modulus minus 3 plus 3 is equal to 0, simply 0. What about this? This is half modulus of minus 3 times I, that is 1, plus 4 modulus. What is this equal to? Minus 3 plus 4 is equal to 1, 1 upon 2. This is equal to 1 over 2, as you may observe. So these are the values of elements present in the first row. What about the second row? Let's solve for the second row. What do we have over here is, this is half minus 3i. This is minus 3 times 2, which is minus 6 plus 1 modulus. Minus 6 plus 1 is minus 5. The modulus is 5. This is 5 by 2. What happens in case of A22? A22 is half minus 6 plus 2 modulus. This is minus 3 times 2 plus 2. Minus 3 times 2 is minus 6 plus 2. This is minus 4, the modulus is 4. This becomes 4 by 2, which is equal to 2, simply 2. Right? Next one, A23. A23 is half minus 6 plus 3, which is again 3 by 2, as you can observe. In the bracket, in the modulus, you have minus 6 plus 3, which is minus 3. The value of modulus would be 3. A24 is half minus 6 plus 4, which is 1 by 2 times 2, which is simply 1. Minus 6 plus 4 is minus 2. The value of modulus is 2. 2 over 2 is simply 1. This is what you get. A31. A31 is 1 by 2 modulus minus 9 plus 1. What is this? This is actually minus 8. Modulus of minus 8 is 8 by 2, which is simply 4. This is simply 4. What happens in case of A32? This is 1 by 2 minus 9 plus 2 modulus. This is equal to what? Minus 7 modulus, which is 7 by 2. Right? Although you may have observed some kind of pattern, so you can think of that pattern as well. This is 2 by 2, this is 1 by 2, 0, and actually modulus being there, this is 1 by 2, or it could have been minus 1 by 2 as well. Here what you observe is this is 5 by 2, 4 by 2, 3 by 2 and 2 by 2. Similarly, this is 8 by 2, 7 by 2, you will get 6 by 2 and 5 by 2 over here. Let's try to find that, right? 1 by 2, this basis becomes minus 9 plus 3, which is simply 6 by 2, which is 3. How did you get that, right? This is A33, minus 3 times 3 plus 3, minus 9 plus 3. A34 would be half times minus 3i would be minus 9 plus j, which is 4. Minus 9 plus 4, the modulus is 5. This is 5 by 2. And since we know these values, therefore the matrix A, therefore A 3 by 4 matrix would be equal to what? This will be equal to 1, 1 by 2, 0, 1 by 2. The first row would be equal to, or write the first column first. This is 1, 5 by 2 and 4. These are the elements present in the first column. The second column is 1 by 2, 2 and 7 by 2. 1 by 2, 2 and 7 by 2. The third column is 0, 3 by 2, 3. Those are the elements present in the third column. The third column, after the third column, we have the fourth column, that is 1 by 2, 1 and 5 by 2. That is the matrix of order 3 by 4. This is the 3 by 4 matrix for part 1, as you can observe over here, right? I'll get aside for a minute for you to take a look clearly. And yes, next we'll discuss part 2 after this. What does part 2 say? Let's talk about part 2 after this. Okay. So in part 2, we'll talk about a different Aij. Aij is equal to 2i minus j. This is equal to 2i minus j. And you're already used to solving for A11, A12, A13, A14. This is very easy for you. What I'll do is I'll directly construct the matrix this time around. A11 will be equal to 2 times 1 minus 1. A21, this would be equal to 2 times I, which is 2 minus 1. A31 would be actually equal to 2 times 3 minus 1. I can write it as this, yes? That is easy. A12 would be equal to 2 times 1 minus 2. A22 would be 2 times 2 minus 2. A32 would be 2 times 3 minus 2. What happens in case of A13? 2 times 1 minus 3. This is 2 times 2 minus 3, 2 times 3 minus 3, right? A33. A14 would be 2 times 1 minus 4. A24 would be 2 times 2 minus 4, and this would be 2 times 3 minus 4. This is the matrix that we are forming. What are the values of each of the elements? Let's write that. This is, which implies A equals 2 times 1 is 2 minus 1 is 1. 2 times 2 is 4 minus 1 is 3. 2 times 3 is 6 minus 1 is 5. These are the values that you will get. we're getting, right? This is 2 times 1, which is 2 minus 2 becomes 0. Right or not? Yes. This is 2 times 2, 4 minus 2 becomes 2. 2 times 3, 6 minus 2 becomes 4. This is what you get, right? What next? 2 times 1, this is 2 minus 3, which is minus 1. This is 4 minus 3, which is 1. 2 times 3, 6 minus 3, which is 3. This is what I am getting. What next? 2 times 1 is 2 minus 4 is minus 2. This is 4 minus 4, 0. This is 6 minus 4, which is 2. And yes, this is the required matrix. Let me get aside for a bit. And yes, this is my answer for this question over here. Alright. Is that all in this question? Yes, this is all in this question over here. Let's take a look at this question. Find the values of x, y and z from the following equation. Okay. Two matrices are given equal. Now, when two matrices are equal, that is, two matrices A and B, if they are said to be equal, the order should be exactly same. Order should be exactly same, first thing. And each and every corresponding element should be equal to each other, right? Basically, corresponding elements are supposed to be equal. Order should be same. Now, a 2 by 3 matrix and a 2 by 4 matrix, can they ever be equal? No, they can never be equal to each other, right? The order has to be same. For the matrices to be equal, the order has to be same. And here you can see that the order is same. This is a 2 by 2 matrix. This is also 2 by 2 matrix. The next thing that we know is that corresponding element should be equal. So, comparing corresponding elements. Comparing corresponding elements. What do we have? This 4, A11 should be equal to Y. 4 equals Y. This 3 equals Z. This X equals 1. And obviously 5 equals 5. This is okay. And the person asked us to find the values of X, Y and Z. Therefore, X equals 1, Y equals 4, Z equals 3. This is a very easy question, right? This is a pretty easy question. And this is 6th part 1. Next, let us take a look at 6th part 2, which says, once again, find the values of X, Y and Z in this. We have a 2 by 2 matrix over here and a 2 by 2 matrix over here. The orders are same, therefore the corresponding elements must be equal. Let's compare. So comparison gives us comparing implies x plus y. This element x plus y, A11 will be equal to 6. 2 is already equal to 2. Let's not write that. That's not important. 5 plus z equals 5. And the product xy is equal to 8. This is right. These are the three conditions, and this is equation number 1, this is equation number 2, this is equation number 3, let's say. So from equation number 2, we get 5 plus z equals 5 implies z equals 0. This is what I get. 5 and 5 get subtracted. And z is simply equal to 0. This is what I get from the second equation. And x and y are two variables, and we have two equations in terms of x and y. So using 3, I can observe that y is equal to 8 over x. Therefore, equation 1 implies x plus 8 over x is equal to 6. X plus 8 over x equal to 6, which gives me x square plus 8 is equal to 6x, or you can say that x square minus 6x plus 8 is equal to 0, rearranging to form a quadratic. And this quadratic can further be solved by simple factorization by splitting the middle term. This is 8, 8 can be done as 4 times 2, which sums up to 6. So x square minus 4x minus 2x plus 8 equals 0. The factors would be x minus 4, x minus 2 equals 0. and implies that x equals 4 or x equals 2. If x is equal to 4, then y is equal to 8 upon 4. Y is equal to 8 over x, right? So in case of x equal to 4, y is equal to 8 over 4, which is 2, or y equals 8 over 2, which is 4. So the possible answers for this particular case, for this particular equation, the possible answers, can I write those possible answers? Yes. Let me write the answer over here. Answer is x equals 4, y equals 2, z equals 0. This is one of the possibilities. Or x equals 2, y equals 4, z equals 0. X equals 2, y is equal to 4, z equal to 0. Z equal to 0 is same in both the cases. That's the final answer for this question. Let me get aside for a bit for you to grasp everything once again, right? Is that all? Yes, that is all in this question. Let's take a look at this one. What do we have over here? This matrix is equal to this matrix, and the matrix on LHS and RHS are they of the same order? Yes. This has 3 rows and 1 column only. This is a 3 by 1 matrix. This is also 3 by 1 matrix. We can compare directly and we get x plus y plus z equals 9. That's the first element compared. Second element says x plus z equals 5. Third says y plus z equals 7. And we are supposed to find the values of x, y and z. How do you think we should go about doing that? Do you observe that x plus z and x plus z, the equation 1 and 2 can be subtracted? What we can do is subtract equation 2 from equation 1. 1 minus 2 implies x plus z gets cancelled, y equals 4. Okay, there are 3 elements over here, 2 elements over here, and 2 values. This get cancelled. Similarly, 1 minus 3, what does that give us? X plus y plus z gets cancelled, x becomes equal to 2, as you may observe, right? X is simply equal to 9 minus 7, which is 2. How do we find the values of z? Once we have x and y, we can use any of these equations to get the value of z. Let's use equation 2. Equation 2 gives me x. 2 plus z equals 5 implies z equals 3. Right? That's what we have. Therefore, answer x equals 2, y equals 4 and z equals 3 is my final answer for this question, as you can observe clearly over here. Okay? That is all in this question for us. Let's take a look at this question. Find the values of A, B, C and D from the equation this. Now there are 2 matrices which are given to be equal, and we are supposed to find A, B, C and D by forming the equations. How do we form the equations? We have to compare the corresponding elements, right? This is a 2 by 2 matrix, this is a 2 by 2 matrix. The corresponding element should be equal. That's what we are supposed to do. So comparing, what do I get by comparing? Is A minus B. This first element should be equal to this minus 1. That's the first thing. What next? This 2A plus C should be equal to this 5 over here. Then 2A minus B should be equal to 0. And this element 3C plus D should be equal to 13. And using these 4 equations, we are supposed to find the values of A, B, C and D. Now how do I go about solving? 4 equations, how many unknowns are there? A, B, C and D, if there are 4 unknowns, theoretically we should be able to solve these number of equations, right? How do we go about solving this? And if you observe, D is only present in this equation, right? So there's nothing we can do about D. C is also present here and C is also present here. C is present in 2 equations, but the other 2 variables are A and D along with them. Right. So these equation number 2 and 4 cannot be solved simultaneously, but equation number 1 and equation number 3 contain only A and B. So solve them to get A and B first. Using that, we could get the value of C from equation 2. Using the value of C, we can get D from equation number 4. So first we are only supposed to worry about equation 1 and equation 3, and you can observe that minus B, we can subtract these two equations to get the value of A directly. What we'll do is equation number 3 minus equation number 1. Equation 3 minus equation 1. This is 2A minus A will be equal to A. Minus B, minus of minus B will be plus B, gets cancelled, and this will be equal to 0 minus of minus 1, which is equal to 1. A is simply equal to 1. That's what I observed from here. A simple step. Therefore, from equation 1, what I get is 1 minus B is equal to minus 1, or we can say that B is equal to 1 plus 1, 2. Right? B comes here and minus 1 goes on the LHS. We get B is equal to 2. Once we have the value of A and B, we can find C using equation 2. What does equation 2 say? 2 times A plus C, which is 2 times 1 plus C is equal to what? It is equal to 5. So let's write it, right? On the RHS, we have a 5. This gives me C equals 3. 2 plus C equals 5 gives me C equals 3, and what next? We are supposed to find D after that, right? Once you have the value of C, use equation 4 to get the value of C. Sorry, to get the values of D. What do we have? This becomes 3 times C, which is 3, plus D equals 13. This gives me D equals 13 minus 9, which implies D is equal to 4. That is all in this question. These are the values of A, B, C and D, as you can see over here. Let me get aside for you to take a complete look on this, right? That is all in this question. Let's talk about this question. A is equal to Aij m by n is a square matrix F. So we are supposed to comment about the order of a square matrix. Okay, that's pretty silly. Square matrix, a square matrix is obtained when the number of rows and number of columns are equal. Right? This is a square matrix, right? This having 2 rows and 2 columns is a square matrix. We could have had 3 columns and correspondingly 3 rows, right? This is a square matrix. The important thing for a square matrix is that number of rows must be equal to number of columns. That is, M should be equal to N. That's the important condition. Which of these options is true? The correct option for this question over here. There are 4 options given. Yes, this is a multiple choice question, and the correct answer for this is C, as you can observe over here. Let's take a look at this question. Which of the given values of x and y make the following pair of matrices equal? Okay, there are 2 matrices given, and if these 2 matrices are equal, then for what values of x and y are these matrices equal? Or conversely, can we also say that if these 2 matrices are equal for some values of x and y, find those values of x and y. That's what we are interested in, right? If you can actually find some values of x and y, right? Because there is one of the options which says that it is not possible to find any such x and y. Let's try to solve using a general approach that will compare these 2 matrices. Okay? Which of the following given values of x and y make the following pair of matrices equal? Okay? So let's compare. What do we get? 3x plus 7 should be equal to, this element should be equal to 0. Okay? 5 should be equal to y minus 2. Okay? Y plus 1 should be equal to 8. And 2 minus 3x should be equal to 4. You can observe there are 4 equations that we are getting, but variables are only 2. There are extra equations, yes. So there is a chance of discrepancy, right? There is a chance of inconsistency between these equations. So we'll have to solve for x and y and check whether we are getting the same values or different values. This is equation number 1, equation number 2, 3 and 4. There are 4 equations. From the first equation you can get x, okay? So as well as you can get the value of x from 4th equation as well, right? Okay, so let's find x from first equation. This is 3x equals minus 7, which gives me x equals minus 7 by 3. From the 4th equation, let's try to find the value of x once again. What do we get over here? This implies 2 minus 3x equals 4, or 2 minus 4 is equal to 3x. Minus 2 is equal to 3x, and yes, there seems to be an issue over here. The value of x should have been same from the two equations. We are getting, in one case we are getting the value of x as minus 7 by 3, in the second case we are getting the value of x as minus 2 by 3. So there is an issue, right? For x equal to minus 7 by 3, this will get these two elements would become equal, but these will not be equal. For the other value of x, this would be equal to this, but this will not be equal to this. Okay. Why are you not finding y? Let's find y also. We can, but there's no need as such, since what I'm saying is the values of x obtained from 1 and 4 should have been same, and the values of y obtained from 2 and 3 should have been same. Herein lies the problem. The values of x obtained from 1 and 4 are actually not same. So therefore, it is not possible to find any possible x comma y pair for which the following pair of matrices are equal. It is not possible to make these two matrices equal, as you can observe over here. For that matter, what would be the value of y? Y, as you can observe, would be 7 in this case and 7 in this case as well. So for y there is no issue, but for x, yes, there is an issue, especially in this 3x plus 7 and 2 minus 3x. Both of them cannot be equal to 0 and 4 correspondingly. That is, 1 and 4 cannot be satisfied simultaneously. Had there been some common solution over here, it would have been very easy, and yes, that would have been our answer, but right now, no. There is an issue in this one. And yes, therefore, these two matrices, it is not possible to find any x and y for which these two matrices are equal. That's what we have, right, in this question. Please note this complete. I'll get aside for a minute. Yes, and that is all in this question. Let's take a look at this question. The number of all possible matrices of order 3 by 3 with each entry 0 or 1 is, okay, that's what we are supposed to find. Number of all possible matrices of order 3 by 3 with each entry 0 or 1, 3 by 3. Now a 3 by 3 matrix would look like this: A11, A12, A13, A21, A22, A23, A31, A32, A33. This is what a 3 by 3 matrix looks like, and the person is saying that Aij is equal to 0 or 1. The number of all possible such matrices, so this particular value A11 can be either 0 or 1. Okay, so number of matrices, what I'll be getting is, we'll apply some concepts studied in permutation combination. That is, this particular value can be either 0 or 1. There are two possible choices for this. A12 once again can be 0 or 1. There are two possible choices for this. Right. This and this and this. And similarly for A21, A22, A23, tick, tuck, 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 tuck. What do you get? 2, 2, 2, 2, 2. 2 times 2 times 2 times 2 times 2. How many times do you multiply 2? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is actually 9 times multiplied. This is 2 power 9. And what is 2 power 9 equals? 2 power 9 is equal to 512. Oh, have you memorized 2 power 9? Yes, I have memorized 2 power 9. How did you memorize 2 power 9? The powers of 2, most of you are familiar with powers of 2. I'm assuming that. If you're not familiar with powers of 2, you should become familiar with powers of 2. Those of you, some of you would have played the game 2048. Yeah. And yes, you encountered powers of 2 over there. 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32. This is 2 power 5. 2 power 6 is 64. 2 power 7 is 128, 2 power 8 is 256, 2 power 9 is 512, 2 power 10 is 1024. 2 power 11, next multiple of 2 would be, next power would be 2048, right? So these numbers, generally people are familiar with these numbers, right? These are actually powers of 2, but which powers of 2 are important? So that you don't get confused, right? You know that 512 comes somewhere, but which power is 512? So for that, what I do is I remember, I'll ask you to remember 2 power 5, 32, and 2 power 10 is 1024. Now if you remember that 2 power 10 is 1024 and you remember that 1024 divided by 2 is 512, then 2 power 9 is actually equal to 5 power 512 over here. This can be written directly without worrying about anything too much, right? If you remember these two powers, 2 power 5 and 2 power 10, you can imagine the others very easily, right? Is that all? Yes, that is all in this question over here, right? And yes, with this we come to the conclusion of this exercise, this particular session of exercise 3.1 based on matrices chapter 3 of class 12th.